Hi everyone. So today we'll study confusion and diffusion property. So basically we have multiple encryption techniques and each techniques converts the plain text into ciphertext. So basically we want that these two properties should be there in our encryption techniques. First one is confusion and second one is diffusion. We want these two properties to be satisfied by our encryption algorithm. And so let's study what actually this confusion property is. So this property simply says, suppose ciphertext is available. So by looking at the ciphertext, I may not be able to guess what actually its corresponding plain text, and neither its key nor the encryption techniques. So if I am not able to guess any three of them from the ciphertext, it means that there is confusion property in our encryption algorithm. Okay, so let me read again. Confusion is a cryptographic property in which the relationship between the encryption key and the ciphertext is made highly complex and unpredictable, so that an attacker cannot determine the key even after analyzing the ciphertext. Simply, if attacker is trying to analyze our ciphertext and he is not able to determine what actually its plain text, key and the encryption algorithm, it means that there is confusion property. Okay, so how can I achieve this confusion property? This can be achieved by using the substitution operations. Suppose if I have used substitution operations, like I have substituted something like this one substituted to this one and this one substituted to this one. If I have used these types of things in my algorithm, then definitely there is a confusion property. Okay. Next one is diffusion. Diffusion simply means if I change my plain text slightly, if I change my plain text slightly, then there is a lot more change in the ciphertext. This is I want actually. Okay, again repeating, suppose there is a slight change in the plain text, then I want significant change, lot more change in the ciphertext. Why actually I want these changes? Because suppose if there is one bit change in PT and there is one bit change in ciphertext, okay, then actually what will happen, the attacker can easily identify that this bit is mapped to this bit, so attacker may be able to guess some text. Okay, so that we don't want. So that's why what we want, if I change even one bit, if I change even a small here, then I want more change here in the ciphertext. So this is the property about diffusion. Okay, let me erase. So basically making each plain text bits affect as many ciphertext bits as possible. Okay, so even if a small bit is changed in the plain text, so it will affect many ciphertext bits. This is we want. And or I can say one bit change in PT corresponding to significant effects on the CT. PT is plain text and CT is ciphertext. That even one bit change in plain text leads to significant effect on the ciphertext. And how we can achieve? We can achieve this using permutation or transposition operations. Okay. Now next is again we have two more things, that is stream cipher and block cipher. Both are encryption techniques. Let's see what this stream cipher is. Stream cipher, what it do? Simply it encrypts your data one bit or one byte at a time. What it does, it encrypts one byte or one bit at a time. It means it operates on bits. Like it takes one bit and corresponding to that one key and encrypts it, and takes the next bit and next key and then again encrypts. So actually it operates on bits, or I can say one byte, that is 8 bits. Okay, so this is about the stream cipher. And what happens in block cipher? In block cipher it does not encrypt one bits at a time, rather it encrypts in a blocks. So in block cipher there are blocks, like we'll study two algorithm. First one is DES and next one is AES. So in DES, so it's already defined that it will take 64 bit at a time, 64 bit input at a time, and that we call it as block. Okay, so in DES 64 bits will be called as a block, and in DES it encrypts those 64 bits at a time. Okay, so in block cipher basically what happens, there is an encryption, but encryption in blocks. In a similar way, in AES we call 128 bits. We grouped 128 bits together and that we call it as a block. So in AES the algorithm uses on 128 bits at a time. So this is actually block cipher. Okay, so thanks for watching.